Thank you for a great introduction. Good morning, everybody. Hope everybody's well. Thank you for coming to hear what we've got to say this morning. Hopefully this is working through. Because of the introduction, I can jump through my background. I don't really need to tell you anymore. Let's jump through PGs as well?
Same for me.
Yeah. Okay, so what we want to talk to you today about is product analytics through the lens of conversion experiences. So as Sophie mentioned, she mentioned that I work in conversion experiences. PG's in the same product group as me, so we thought we'd try and bring a really good balance of data engineering and data science information for you. So first of all, let's try and sort of debunk, when we say product analytics, what do we actually mean? So we can think of product through the eyes of what I would call a personal user. So here we've got obviously Facebook Messenger, Instagram, WhatsApp, Workplace, Oculus. Is there anybody in the room that has never used one of these apps before? And I have to shield my eyes because it's really bright up here. Right, so everybody in the room has got some concept of the product through the personal user lens. Okay, so we can also think of this through the business user lens. So again, another show of hands. Has anybody used Meta Business Suite or Ads Manager to create their own ads? We've got 1, 2, 3, 4, so a really, really small percentage of the audience. But we would class that as a product as well. So we think it's not just these apps that you see, that you've probably all got on your phones, it's also other products that we are more business focused. And then within that business focus, we have different ads formats. So we have static ads, dynamic ads, shops ads, etc. And we would class each of them as a product as well. So product in this sense is a bit of a catch-all, but fundamentally it shapes how we structure teams and how we try and deliver things at Meta. PG is going to cover some more of how we build a bit later on. So then we think about analytics. So why do we need analytics on products? So we have to measure the performance. We need to make sure that these products are actually doing what we wanted them to do. We use analytics to help shape strategy, so the products don't stand still at all. And we also have them to drive accountability. So when we talk about product teams, each of those product teams will have goals. We need to make the product teams accountable for reaching those goals. So trying to bring this to life a little bit. So as I said, both PG and I work within conversion experiences, which started life as shops. And shops in this sense would be the product that I want to talk about. So if you think we're part of monetization, so we have, Meta doesn't mind using the word monetization. We're there to make money for Meta, and we make money by providing value to advertisers. So what we want to do is create products that improve what we call their return on ad spend, or ROAS is the shorthand for that. So if we can get better ROAS for advertisers, it means they're getting more return on their investment with ads. So we launched Shops in 2020. So this was really a response to the pandemic. People weren't able to go out and do their normal shopping in bricks and mortar stores. And a lot of very small businesses didn't have a transactional website. So we created Shops to try and help these small businesses build something to continue their revenue streams during that. And the concept was really simple. Create an online shop within the Meta ecosystem. Provide Meta with product information, images, descriptions, stock level, prices, all of that stuff that you need if you're going to go shopping. And then run adverts on both Facebook and Instagram and drive traffic to that online shop. And then get good conversion rates and actually sell more. Now, products evolve. So I realize you might not be able to read this. I have to keep shielding my eyes because it's super bright up here. You might not be able to read all of that. Oh, you can behind me. Fine. So products evolve. So post-pandemic, people's shopping habits switched back away from e-com. People were desperate to get out of their homes and they wanted to get back into those physical stores. So the focus was less on shops being an actual product in itself. So the concept evolved into what we call shops ads. And that's a specific advertising format, which when you click it, if you click on an ad that's a shop ad, it lands you on a Meta-hosted online shop as opposed to the seller's own website. And what that gives us is it gives Meta the ability to personalize that, what we call the post-click experience. We know a lot about you from all of the things you do on our platforms, and we're able to personalize that experience and hopefully move you through that conversion funnel. So I'm just going to try and bring that to life. So I said ad impression. So by impression, we just mean you've been shown something in your newsfeed. When that's clicked, we have this thing called destination automation. So there's an ML model that works out whether you're more likely to convert either on your on-site shop or more likely to convert, when I say convert, I mean go through to purchase, on that advertiser's own website. So that the model optimizes for the conversion and would just drive traffic in that way. So in reality, hopefully this is me, this is my actual feed. And I'm working through here, so I've got some pre-click information starts as my journey starts. I'm obviously looking at fire pits at the moment, so it keeps popping up on my feed. This pops up, I can click through, so we've gone into the online shop, I'm on the storefront there, I'm browsing through the storefront, and then I can pick a specific product in a moment, let it catch up. I must scroll very slowly. I pick a specific product, and it take me to that product page, and I can choose whether I want to add that to my basket, and I can choose whether to check out on the on-site shop or whether I check out on a retailer's website. And this is very, very simplified. So this is me going through that conversion process in a single session. So in reality, if it's a big ticket item, I might go and do a bit more research. I might come back maybe a few days later. So we have to have this concept of being able to join sessions together to get the right level of attribution back to that advert.
Yeah. So why don't we now visualize these in terms of a simple funnel? At first, we have the pre-click, which is where our models decide what to display to the people using our applications. There onwards, we have a visualization of this advertisement as a container. Here we have a click to action. Basically, it's like the click-through rate that you can think of in normal ad business, whether or not the people using the application end up clicking on the ad. And this is where our post-click experiences start. For shop ads specifically, this is where our on-site representation of the shop takes place. Skip forward a little bit, you end up having a choice for the people, which is whether or not to add a product to the cart, and this culminates in an eventual checkout, and hence in a purchase. For all of these stages, you have opportunities for personalization, opportunities to link sellers and buyers together to get this kind of like monetization going. Now, in terms of personalization, we think about it in the terms of like a triangle. There are three things we really care about. As I was saying, there is a buyer, a seller, and finally there is a product. And we want to match the three of them together in the most performant way. From a data standpoint, this takes the form and the shape of attributes, dimensions. So from a buyer attribute perspective, you can think of it as whether or not the buyer previously decided to follow the shop on Instagram. From a product perspective, you can imagine the price point being an important element. And from a seller perspective, the vertical clearly plays a role. You might be more into fashion than you are into beauty. All of these has the objective to eventually provide the best user experience and to drive the conversion. And this is all achieved through ML models that are like bringing this all together to life.
Right, so let's, we've talked about personalization in terms of theory. Let's try and sort of see what that could look like in real life. So thinking of the Facebook app as the platform. So we can see opportunities such as dynamically changing the layout to show the user the previous products that they viewed. We can combine different products to try and build outfits. So here we've got a trousers and a t-shirt, a jacket as well, probably on the next pivot along. We can personalize sections of the storefront. So I explained the storefront before when I was scrolling through the Fire Pit app. And here we've got a cosmetic shop that's showing personalized sections that might be appropriate for that user. Or we might want to show personalized offers. So we might want to give some money off for that specific user if we know that's what's going to trigger them to actually go and convert. Now, if we think about Instagram, so Instagram's obviously much more graphical, a lot more moving images. We think we've got the example here. We can jump from a reel, somebody doing some yoga workout, jump into to those yoga clothes that the person was wearing. Or we can use AR. So we've got some trainers here, so we can use AR to show what they look like on your foot as a personalized opportunity. Reconsideration options. So if you're using Instagram, you know that you've got your stories feed at the top, so we can actually pop up some things in that feed, say, you looked at these last week, what about them? Do you want to go back and find them again? And then the last one is the social experience of shopping. So you can see a product, then you can hook to a friend, have a chat with your friend while you're both considering that product. Is that chair going to look nice in your house? These are just examples of how we might want to personalize. So, big question, does it actually work? And this is very much sort of the topic that PG is going to cover later when we talk about experimentation. So in order to work out if this works, this is where I come back to the analytics side of product analytics. So we need to do lots of experimentation. So we all like glossy pictures, we like cool shopping features, but what we do is when we run our shops ads, we run many, many different versions of them, and we're able to work out which ones perform better. So we know from analysis that we get an average 35% incremental ROAS, remember return on ad spend, when an advertiser uses shops ads versus website only. That's because our ML models are optimizing that conversion surface.
And now, rather than looking at it from a funnel perspective, we think about how this all comes to be from a process standpoint. Of course, there is an ideation stage where we come up with ideas and we brainstorm what might work. We then validate these through user research to make sure that the jobs to be done of the product and the buyer needs can be fulfilled. We then enter a loop of planning, which is fundamentally an alternation of design, building, testing, and evaluating the features that we build. At design stage, we come up with multiple options of how the same buyer need might be fulfilled. We then end up building a few of those, sub-selecting from the total. From there onwards, we test it through experimentation, and eventually we evaluate whether or not the new experience drives increased performances. Once this is all done, it could well be the case that the feature is not performant yet, and if that's the case, we iterate on it. We find new ways to fulfill the job to be done, and we repeat the loop, until finally we end up deploying the feature to production. Now, this is probably my favorite slide, and it's about the people. Our teams are primarily encompassing software engineers, which are the people that really make the magic happen. Software engineers are managed by an engineering manager, but there are lots of different people that need to support this small team of engineers, and this includes the analytics folk as data engineering and data science. But then also we have user research and product design, project management, and all the kind of like supporting functions that make the magic happen. In this representation, there is a nice kind of little container around all of this, but the reality of how work happens in a company of this size is that teams cross over, there is chaos around how things happen, and so a person that works on one team and on one project might just as well be working on some other stuff. And it's our role to kind of bring some order to this chaos, so we normally try to organize the work into three concepts. This is priorities, work stream, and tracks. Priorities are themes that our products need to kind of focus on and trying to improve. Work streams are centered around an objective. They're about the optimization of something. It could be about the efficiency of our engineers, but it could be about this ROAS that Michael was talking about, return over ad spend. And finally, we have tracks, and tracks are about a vision, a mission. It's about accomplishing something greater. And using all of these three frameworks, we get our teams to work together in a streamlined way. But so you might ask, what is the role of analytics in all of this? Well, there are four sections that constitute a life cycle in our view. The first one is about foundational capabilities. We're looking at designing the correct data architecture for our needs. We're looking at logging this data effectively and efficiently in a consistent manner across a wealth of applications. As Michael was saying, we have many products in our portfolio, and we want to make sure that whatever is done in one is comparable to what is done in another product. We then have different kind of optimization functions, like we want for our data scientists to be able to query the data in an optimized way, in an efficient way, and we want to be able to monitor all of this. This is the important part. We want to set goals for our team, and we want to be able to check whether these goals are being accomplished, and we want to know when the performance of our product deviates from what we expect it to be at any point in time. And this is why we set up anomaly detection systems. And when these detection systems tell us that something is not going quite as expected, we carry out root cause analysis to understand exactly the reason why the product misbehaved. From there, we finally get to the strategic insights. We have now a goal, we have something that we want to accomplish, and we ask ourselves what's the best way to get there. And to get this done, we tend to have opportunity sizing at a strategic level. That means things like, is it worth investing in this area rather than in this other area? And at the same time, we do exploratory data analysis. Now, this differs from opportunity sizing in the sense that we don't know whether or not, we don't know the area that we want to evaluate. We are seeking for one. We're seeking for something in our product that indicates we have a new opportunity that we haven't considered before. Finally, we need to operationalize all of this, because otherwise it doesn't happen. And the operationalization entails, yet again, a new stage of opportunity sizing, where we look at the pitch, at the result of a brainstorm for a feature, and we try to understand what we expect the performance of this feature to be. We finally get to probably the bulk of the work, which is experimentation design and experimentation analysis. We need to make sure that these features are performant in production, so that both the seller and the buyer needs are fulfilled. And as Michael was saying earlier, you know that personalization kind of underpins all of these, and personalization is accomplished through ML models. We want, just as well, to make sure that our models are performant when we build them, and they don't drift over time, so that the performance is consistently provided in a well-governed manner.
Right, so while you look at my brilliant Gen AI created cartoon character of a data engineer, I'm just going to do a quick recap. So hopefully you've now all got a really good understanding of what we mean by a product. And you can see that products, they evolve to cater for change. That can come from a multitude of different places. And hopefully you've now got a sense of how analytics plays a huge role as part of this evolution to inform and influence. And what we're going to do now is going to spend a bit of time focusing on the two key roles. It's not the only two roles in analytics, but it's the two key roles within meta-analytics. So data engineering. So now you've seen my wonderful cartoon. Let's jump on to what data engineers in Meta actually do. So this breaks down into two bits. We've got the deliver the data artifacts. So what do we mean by that? So first of all, login specifications, standardized queries, pipelines, tables, visualizations, and then the bit that nobody likes doing, a lot of people don't really want to do, data documentation, building wikis, making sure that users of that data understand what the limitations are, what the caveats are around it, where was it collected, what does it cover, all of that. And then come on to the second bit, the data-informed decision-making. So we do this through creating dashboards, just visualizations and so on, and also robust data sets that can be used for analysis. So what does that entail? And the difficulty here is now I can't read what's on there. So some common tasks on here. So what I'm going to do is the structure that PG showed, I'm going to sort of build that through the lens of a data engineer so you can see the bits that data engineering focus on. So first of all, modeling and architecture. So we implement the end-to-end data management. We define what data needs to be collected. We normally work with software engineers to define those specifications. How should that data be stored? How should it be arranged, integrated, and put to use? Governance, this is really key. So governance through the lens of usability, availability, integrity, security, privacy, I didn't put on here, and that needs to conform to internal and external policies and standards. Programming. So we are data engineers, they're pretty proficient in Python, SQL, maybe Spark, a few other languages as well. Some are pretty good. The code that we use to drive our web-based development. Integration, so that's how do we bring data from multiple sources? How do we make sure that it fits together, that we don't get different numbers from one source to another when they ought to be correct? And then visualization, so I mentioned about building dashboards and so on. And then at the bottom, the database management. Some more operational work, making sure that we've got basic hygiene in place, so we don't have multiple tables of the same type, we don't have overlap, people know where to go and find things. But it's not just about the tech. So what else does it entail? So ownership. So we have to establish our data engineers as product owners, domain specialists of that data. Autonomy, so they need to be able to go and work out what do they need to build. We tend to do road mapping every half of the year, so every 6 months. What do we need to build from a data roadmap perspective that's going to help build the data sets that answer those business questions to help those product roadmaps? Collaboration. PG showed that slide about how a team works. Lots of collaboration between our cross functions there. So DE working really closely with DS, working with software engineers, product managers, etc. Leadership. So these are standard things that we would expect, not just the tech stuff. Influence, so how do we influence not just different products, how do we influence other data engineering teams, that if one team's built a framework that could have scalability across the whole of Meta, how do they influence that? Okay, so where do we get data from? So this is the real world. This is me doing something on the app, and I'm either looking at a website, looking at I'm sorry, I'm using this fire pit example all the way through. See, I'm very interested in fire pits at the minute. We've got me looking at the storefront on the app. So everything I do on that app can be captured. So we can log it or we can scrape it. So logs, pretty straightforward. It means we've got a piece of code in that app. When I go through that process, like through that piece of code, it'll log the who, the where, the what, the when. So we can start to build this sort of event stream up. A scrape is a little bit different. So if you think about how our apps are built and deployed, we use something called TAO, which stands for the associations and objects. So you think of those objects have transient values connected to them, and they can change over time while you're in a session. A scrape is at a point in time we go and scrape the actual values of the object. So it's how we get data into our warehouse as well. And then a standard way of looking at data, but obviously we're working at vast scales. We're looking at billions of rows of new data per day. So if we look at that in more detail, I want to focus on the logging bit in more detail. So we can have multiple logging frameworks. And the reason we don't just have one logging framework is because we might build a frame, say we build framework A, because that's the best way to build something at that point in time for where that product is on its maturity curve. And then maybe 6 months later, we might come up with a new logging framework. So we might use framework B on there, but we never get return on investment if we go back and rewrite all the logging for the previous one. So we just manage to have multiple logging frameworks. And that's fine, because we also have longitudinal logging. And this, I mean, from me opening the app to clicking on something to going through all of the bits of that circuitry, the non-linear way of going through the storefront, the PDP, product description page, onto the cart and then purchasing. That's fine to have longitudinal. Now the key thing is that where these logging frameworks intersect, we can have consistent values, because we need to be able to say that we can aggregate from the very detailed logging up to the other. Now the analogy I use here is, I've got a geographic background. I love maps, so I thought I'd stick a map in here. The logging framework would be the equivalent of a large-scale map, so we can see road outlines, we can see building outlines. And then the longitudinal logging is much more of a small scale, so we've zoomed right out. We can see that we've just got towns are either sort of blobs of shading or just little circles, and the roads are not to scale. But actually, they're not actually of the same location, but if they were, then they would fit together in geographical space. How do we make that data available? So pretty standard. So here's lots of people. It's right at the bottom of the screen, so you might not be able to see it. Real world activity going on. People doing things, clicking things. And that gets captured into this raw data layer through logs, through scrapes. Then we start to apply business logic. We start to apply metric definitions to this, and we start to abstract away from the real world. So we might have a staging layer. We might have more than one staging layer. Depends how complex things are. We're always looking at compute efficiency versus storage efficiency. Again, working at the scale of data that we work at, that can have a massive impact on us. At some point, we would build what we call a consumption layer. So we're happy for other people to come and use this data. It's gone through all of the consistency checks, the anomaly checks, and so on. We're pretty certain this data's right. And then we might build a visualization layer that could go off and serve some form of dashboard. So we would say anything below that line, below the tick, is stuff that we would work with in data engineering. Anything above that line is fair game for people to go and use. Hopefully it's associated with some comprehensive data wiki to explain where that data's come from, what's been done to it, so you know if you're doing a piece of analysis that you're making the right assumptions on that data. But data engineering and data science, they're not mutually exclusive functions. There is an overlap between them. And it's how we work that overlap which gives us the power that we have at Meta. Also software engineers, machine learning engineers. So I've drawn this as a Venn diagram. I feel the prize is in the middle. When we can collaborate between all three of these functions, then we get this big win of real good success for the product.
Equally as before, we have a Gen AI image of what we believe a data scientist might look like. But what do we do in our day-to-day basis? Well, there are three things that really come in play that you heard about before: strategy, performance, and accountability. At the strategic level, we want to make sure to identify and size correctly the opportunities in front of us. At the performance level, we want to make sure that our products are performance, that our changes and features deliver the value that they promise. And at an accountability level, data scientists try to make sure that all these cross-functional teams deliver what they decided to deliver at the beginning of the time period. And in a day-to-day basis, this translates to the following. There is an element of setting and monitoring goals to make sure that progress is being made throughout the half. There is an element of sizing opportunities, so understanding exactly where to invest, but equally as important, where not to invest. There is an element of driving experimentation, and I would say that depending on the team you're part of at Meta, this might represent the bulk of your work to drive this experimentation layer. And we'll see in a second why this is a little bit complicated. But in different teams, you perhaps are more invested into assessing and evaluating model performance, just like I was saying before. You want to know that your model doesn't drift, doesn't regress, and that the performance holds across different cohorts of sellers and buyers alike. No difference here. We are not only about tech, we're about people, and we need to work together effectively. And so just like you heard before for the expectations of data engineering, data science is no different. We want to have ownership of areas and projects. We want to be autonomous in how we conduct and we bring those projects to conclusion. And we want to collaborate across, et cetera, et cetera. Now, I want to double-click for a second on experimentation. This is an attempt at capturing a standard experimentation lifecycle. You have a first step, which is about defining hypotheses, goals, and guardrails, guardrails being metrics and measurement that we want not to regress. It's about ensuring that we set up our experiments with the correct sample size, power, and power. It's about a rigorous assessment of the results, which is paired with a slightly less rigorous deep dive after an experiment concludes. Now, why do I use these keywords about rigor? I think that there is a moment for data scientists to be really in the weeds of statistics and making sure that we tick all the boxes and we do everything correctly. And then there is an element of getting driven by our product sense and making sure that we actually understand what's really going on in our features. But now the point is that scale, just as it is a complication for the data engineering flows and scope, it is a complication for data science as well. We, in Shop Ads, run around 500 experiments per year. And this poses a challenge just from a logistics standpoint. You're probably familiar with what the normal runtime of an experiment is. Just getting every team to do it at the right point in time requires a lot of chasing and a lot of coordination. You have upstream ML models. Now, as we were showing you before, there is a whole funnel of ML that gets in place. But of course, if someone changes introduces a new feature in your upstream ML model, this will generate a mix shift that you need to account for and deal with. False positives, false negatives, and false discovery rate. This is a very difficult balance to strike in practice, because in one experiment, it's a very easy choice to make what this might look like healthy, to the point the statistical books will kind of hard code you into a number. But when you have 500 experiments in your hands, some of which are more riskier bets and some of which are like safer bets, you need to decide this in a systematic manner that is not only consistent but fair to teams. And then you have downstream product changes, so it's the flip coin of what I just said. If you're trying to optimize your ML model, you need to have your optimization function trying to target consistent experiences. But these experiences are never consistent. They change all the time. And finally, interactions. 500 experiments is a lot of experiments, and that means that some of them will cannibalize each other, or in the best case scenario, generate a positive interaction. And you need to kind of detect these and account for it with a stable and reliable experimentation process. Thank you, everyone. I will leave to Michael the next slide.
Thanks, PG. So before we go to questions, I thought we'd just do a quick overview of what other product teams have presence in London. Obviously, Meta in London is a relatively big part of our organization. Most teams are global. For example, my team covers 7 time zones across Europe and the US. In London, specifically for analytics, we have WhatsApp, Reality Labs, Integrity, Customer Support, Messenger, Privacy, Marketing, and others. We have a booth downstairs, a stand in the corner. Please go and visit. We've actually let some of our data engineers and data scientists out for the day, and they're here. They can talk to you. Any questions that you've got about Meta, we've got some swag to give away. We've got some 5 easy questions for Meta, so please enter that. So go and visit the table, enter the competition. And any questions from PG or me on what we've talked about?
Thank you for the talk. It was very interesting. I have 2 questions. The first one is related. You mentioned anomaly detection. I'm here, by the way. So I just wondered how do you deal with anomaly detection? Like, do you have your own Python scripts and things like that, your own code, or you rather rely on software, on companies that
anomaly detection? Did you say?
Yeah. Basically to make sure that your data, to ensure that the quality is good. And the second question is related to, you also mentioned do you have a lot of processes to deal with the architecture, and I guess you have your different pipelines in terms of coding, and as in any company, there are a lot of people involved in every project. You have your PM, your designer, your data scientists, your data engineers. How do you make sure that everything kind of is aligned? Like a Meta, do you have a lot of maybe workshops where you just make sure that everybody's aligned and with the business, ask what each of those, I guess, leaders want, the one that is looking after what the user wants, the one that is the aesthetics and whatever. Do you kind of agree on something beforehand and then go to implement it, or you kind of start going for it, implement it, and kind of realign it or reshape it as you go? Because I guess that it's going to be, as we all know, very hard, to make everybody happy, because everybody is going to want to have their own goals implemented.
Okay, I think I've got the grasp of those. I'll go first, and then PG, you can jump in with anything. So think about anomaly detection first. So think about it from a data perspective. So as we build our pipelines, we will add data quality checks into those pipelines. But that's more about making sure we've got the right data integrity. We're not sort of processing a day partition with fewer records in than we'd expect to do. Simple things like that. But we do have some fairly sophisticated ways that we look at how that data is changing over time. Obviously, with an app like Facebook itself, there's some form of seasonality to it. So if we get round, especially for the US, if we get round sort of Thanksgiving and so on, you'd expect to see values go up. If we think about our business apps, our workplace, which is the area I used to work in, we'd have a very different weekly pattern of data volumes in there. So we have models that look at whether data sort of trending in or outside of different norms, and we can have automatic alerts on that. We go and look at the dashboards on a regular basis. Most of the product teams are looking at those dashboards on a regular basis. If they see something that looks odd, they'll raise a question. It will come to data engineering, data science, do a bit of a deep dive. What's going on with this? But I think the short answer is we have quality checks, and we also have some fairly sophisticated anomaly detection for data sort of drifting out of line. Your second question, if I can just summarize and play it back to you, was about how do we make sure that we're building the right things from an architecture perspective when we've got so many people working on so many different things? Sorry, a summary of that. Is that right? Sorry, it's really bright up here. Yeah, okay. So the way that we tend to do that is we go through a fairly extensive road mapping process. And that road mapping process is done for the product, and then it's also done for analytics. And we do that every 6 months. And so we get the opportunity. So conversion experience is part of monetization. So I would look at all of my other peer data engineering directors. I'd look at their roadmaps for their product areas. There'd be somebody in, say, core ads, which is very similar to shop ads. There'd be somebody in another team. And I'd look at their roadmaps, and I see from a data engineering perspective what sort of potential overlap is there, but also what sort of potential ideas for collaboration there are. Now, if you think that's fine from a data perspective, so we're not going to duplicate what we're building too much, but that's got to be balanced with we have to move very quickly, because we do move very quickly as an organization. And so I think that we often, in reality, will create some technical debt, inevitably create some technical debt just because of the speed we move. And then it's how do we come back and repay that technical debt? Now, from a product perspective, that same process is going on. So all of those product ideas and prioritizations will sort of bubble up, and then somebody on the product side will say, oh, this team's building this over here, but it's going to cannibalize this product over here. So they'll do sort of a bit of a balance across that. I'm not sure I've answered your question properly, but I'll be on the stand downstairs if you want to do any follow-ups. Okay.
Hi, thank you for the talk, very interesting. I would like to ask about in the experimentation with ads. Could you talk a little bit about how do you deal with like heterogeneous effects, like in the results? Like, let's say you run a new feature in the ads, and you're dealing with a lot of shop businesses and different types of customers, and the effect might be not positive for everyone. So how do you make the decision if you're going to roll out or not, depending on how diverse might this effect be?
Yeah, of course. Let me play it back to you. I think that the question aims at understanding whether you globally optimize or locally optimize for a sub-segment of your user base or your sellers. Is that right?
Yes, from that direction.
Okay, so the very first step is that you care about the top line, that there is no escaping this, right? You care about the entirety of the population you're trying to make inference about, and so that's constantly the first thing that we look at. Now, fundamentally, I think every half will have some project running, trying to identify new segments of buyers or sellers that are of interest. At times, these are kind of like just an extension of the advertisement networks that we have. And at times, these are like new discoveries, things that we didn't think about before. And when we run subsequent experiments, we normally have breakdowns according to these dimensions that we look at fairly consistently. Now, we're only 1% done. and we're always only 1% done. And so I think there are like a bunch of challenges in that area, which is, well, now you're looking at, I don't know, 20 metrics with like several breakdowns. How do you ensure that like you're not p-hacking your way into a result? And so normally we try to manage experiment with very clear definitions of ship criteria and objectives so that p-hacking is minimized as much as possible, and so that we can ensure that we are building for a specific segment with a clear job to be done in mind. And so this is, is where beautifully things come together, and UX work, NDE work, MLE work, and data science work finally converge into very clear sets of hypotheses and experiments.
Yeah, so my question is related to the experimentation area. Since you mentioned about 500 experiments per year, right? Which means there are a multitude of teams that are doing it. What kind of measures do you take that an experiment of one team does not have an influence on the analytics of experiment on another team? And how do you kind of clean it up at the end?
Right. This is a very exciting question. I could go on for a while. I don't know how much I can go on, but fundamentally I think that we have automating tooling in place to detect for us if we run a risk of interaction based on the exposure points in our product. So you can decide at what point in the code base an exposure occurs. It could be at the very first moment when you see the storefront, or it could be down the line when you click on the checkout button. These automated tools kind of start flagging as a first layer of protection, whether or not one experiment might interact with another one. From there onwards, you can start handling these bespokenly. So you can allocate a data scientist to kind of look into whether or not the two features might effectively interact. You can decide to study directly the interaction effect between the two things with some sort of like a simple linear regression model with interaction called out explicitly. Or you can set up a kind of like a multi-step experimentation process where at first you accept that an interaction might exist, and at a later stage, you want to test the two features together to have a cleaner read of the impact of the two combined, where the interaction effect is fundamentally baked in. Of course, this comes at the cost of speed.
Hi, and thank you for the presentation. Yeah, my question kind of revolves around documentation. So, of course, you mentioned you have a lot of cross-functional teams. So how do you kind of promote, and people working on multiple projects at the same time, so how do you kind of promote knowledge sharing amongst like team members, teams, and also who owns the documentation? So I'm trying to understand who owns that at Meta and how that process works.
Do you want me to take that?
Yes, please.
Yeah. So we run a piece of software called Workplace. So Workplace is fundamentally a version of Facebook that we run that a company uses. So we have like our own private instance of Facebook that sits within the organization. So in there, I can do a post, I can write a note, I can link to, we also have heavy integration with Google Docs. So it means that somebody can go onto Workplace, they can search me up, they can see everything that I've written, as long as it's in groups that are open that they can read. But if I put it on, my timeline would be open. I'd probably put a link to something that then they might have to pass a security check to see if they're allowed to see that information. But we share very much in that way. I say we use a lot of Google Docs to sort of create, we have templates and roadmaps and so on that other people can then access. But primarily it's through Workplace.
Okay, no, thank you.
Yeah. One more?
Yeah, one more.
Yeah.
Only easy ones though, please.
All right, from the data perspective, I would like to ask what emerging trends in data privacy are influencing product analytics right now? And how do you balance user trust with the need for actionable insights?
So the question is about privacy and the analytics and how we balance the two.
Yeah.
Okay. As someone that had to undergo training less than 24 hours ago, I think that the privacy concerns underpins the entirety of the development process. This is not just analytics. This is like everyone. From the very first moment where an idea gets like spurred in the mind of someone to the very first MVP implementation of it, we think about privacy constantly. Many of the analytics, a lot of the analytics work happens with automated tools which are fundamentally making sure that you meet the privacy requirements that are the Meta needs to be compliant against. And so to the point that if you look at it naively, this might look like a big tax or a painful moment because before starting your analysis, perhaps you need to make sure that everything is in place, and this is going to take time, and we're trying to move fast. But at the same time, it guarantees that we build features with privacy and compliance in mind first. So I think that automation of these steps across the whole of the process is how we tackle this. Cool. All right. I think we're past time, in fact. Thank you, everyone. Very excited to see you all this rainy morning in London. We have the booth downstairs, so please come down and chat us up.